In this video, we will look at an example of an aggregate plan. I have the data from the previous videos here. So these are our demand values. This is the materials cost, the holding cost, and everything. All the numbers that we discussed last time are here. I already set up a few spaces here. Let me clear this out. Right. So we are going to plan for 6 months. All of these numbers here, these are all going to be our decision variables, the ones that we talked about before. I'm gonna color that green, right? These are all our decision variables. So this is the demand for the 6 months that we're planning for, and those demand values are given here. So I'm going to be doing this a lot. I am going to refer. So I'm going to say this is equal to this number here, so that we can make any changes here rather than doing it there. And then just going to copy it down so that the demand values are here. Now I've already set up the constraints because the constraints are pretty complicated. We'll see that in a second, but just reminding you that I've already set up the constraints. We'll get to that in a second. Now, so what we're going to find, there is also a period 0 here, just to keep an idea of what we start with and all of that. So that's something to keep in mind. We are starting with a workforce of 80 people. Let's assume that we are starting with no inventory on hand. All inventory is being manufactured. So I'm going to start with no inventory and no subcontractor, no production or anything from that. So these are the two things that we need from previous periods. And so we have and stockouts are also 0. So that's something to keep in mind. So no inventory, no stockout from previous period. We have a workforce of 80 people to start with, right? So what I'm doing here is the one thing that I'm doing differently from what I did with the capacitated facility location and all the other network models that we did, is I'm going to calculate the costs. Instead of writing a single formula for cost here, I'm going to calculate cost of each individual thing by itself, and then all we'll do for total cost here is just add up all the cost values, right? So that's exactly what we're going to do. So let's keep that in mind. So keeping that in mind, so let's begin with the hiring costs. So the hiring costs are, if you hire anybody in the first month, we know that hiring cost is where's hiring cost? So hiring cost per worker is $300. So we can say that hiring cost is $300, and we'll make that an absolute reference, right? Make that an absolute reference. So $B $17, $300 times, so $300. So this comes from the previous thing, $300. No, I'm sorry, I messed that up. It is $300 right here with an absolute reference. $300 times, why does it keep, sorry about that. So for some reason it doesn't want to refer to the previous. You know what? I know it's $300. For the timing, I'm just going to say $300 here. But it's better to always refer to the previous place, because then if you want to make a change and say that, no, the cost of hiring is not 300 anymore, it's actually 250, then you just need to change it in a single place rather than changing it all over the place. So it's $300 times the number of people you hire, right? So that's the cost of hiring. Right now we have not hired anybody, so the cost is 0. Otherwise that's the cost, and that's the same cost for all 6 months. There's no different cost of hiring. And the same goes for layoff. It's $500. So it's $500 times the number of people you laid off. Okay, let me try this one more time. Times. Okay, that stayed. Times that. Okay, so I'm going to fix that. All right, good. So that's that. And I'm gonna fix this with $B, $17. And then we will copy the formula down. The same here. This is $B, $18. So it's a absolute reference. Let me make the font bigger in case I'm unable to see that. So it's $B, $18 times that. So this is the cost of laying off everybody. So that's the total cost. Now the regular time cost. So remember that regular cost of regular time is the number of workers that you have, right? Times the $640 that you're paying them per month, and we calculated that, right? So how did we calculate that? $640. So it is $40 a week. Sorry. So it is it's $40 a week. Sorry, 40 hours a week times 4 months. So that's $160 160 hours total times the amount of money that you pay them, and you pay them $4 per hour, right? Times the number of people on your workforce. So right there, it's the number of people on your workforce. We are not going to cost the previous month. This is month 0. So this is December. We are not going to cost that. So this is $160 times 4. So that is $640 in total times the number of people you have hired to work. So that, again, I am going to make this $B, $20 because that's the $4 per hour thing. And I'm going to copy this down again, just to be clear, right? So what this does is this calculates here the fact that this is 40 times 4, 160 times another $4 an hour. So $640 per person times the number of people who were working for you in March. So this is January, February, March, right? So number of people who were working for you in March. So that's the cost of regular time. The cost of overtime. So cost of overtime is just the number of overtime hours times the cost of overtime. So we know that overtime cost is $6 an hour, right? Let's make that 4. And then times. So that's the cost of overtime is $6 times the number of overtime hours that you have in that particular month. So for the month of January, number of overtime hours is in E5. So we have that, and then I'm just gonna copy the formula down. So this is the cost of overtime. So $6 times the number of overtime hours you have. So this is the cost of overtime in May. This is the cost of overtime in June, which is again $6 times the number of overtime hours you have. The same goes for inventory. So again, the cost of inventory is $2 per month per unit. So its inventory is that. So again, I'm going to make that an absolute reference. I'm going to multiply that with the number of units of inventory that you have. So if inventory is 0, you're not going to be holding anything. It's not going to cost you anything. Otherwise, it is going to cost you whatever it is going to cost you. The same goes for stock out. The cost of stock out is also $5. The cost of stock out is $5 per unit per month. You can make that an absolute reference and multiply that with the number of units of stock out that we expect starting for the first month. And this is the number of units of stock out for all the 6 months. So you're just going to add up all of these numbers into the total cost that we have here. Same goes for subcontract. Subcontract is $30 an hour. So they got $30. Make it an absolute reference and multiply that with. So remember, subcontract is the number of units that you subcontract. It's the number of units that you're subcontracting. And there you go. That's a subcontract value. And these are all the values of subcontracting. So this is the number of units that you subcontracted in April times the cost of subcontracting, which is $30. Finally, material cost. So material cost is $10 per unit. So it's $10. So again, I'm going to make that an absolute reference and multiply that with the number of units produced in each month in the 6 periods. So this is the total material cost. So you have hiring cost, layoff cost, regular time, overtime, inventory, stock out, subcontracted material. So these are all the cost values, and the total cost is the sum of all of these cost values, right? That's the total cost. Now, all of these numbers here, so these numbers here are not decision variables, so let me get rid of that. So all of these numbers here, these are your decision variables. This is what the linear program or solver is going to give us. But first we have to write our constraints. So just to simplify everything, I am going to simplify the constraints. So if you look at the constraints here, you have workforce balance constraints, inventory balance constraints, capacity and overtime constraints. What I am going to do is, you'll notice that all of these constraints have just variables in them. There are no constants, which means it's not like WT is less than, PT is less than or equal to 100 or something like that. They all have, they all have just variables in them. So for the workforce constraint, I'm going to rewrite this workforce constraint as WT minus 1 minus HT plus LT. So essentially what I'm doing is I'm taking all the variables that are on the right hand side and I'm subtracting them from the left hand side. That way the right hand side is 0 and the left hand side is the value of all of these constraints. So when I write the workforce constraint, you'll notice that it says you start with D5, which is the workforce for this month. So careful, so it's workforce for this month minus the workforce for the previous month, plus the number of people you hire, minus the number of people you hire, plus the number of people you lay off. So minus the number of people you hire, plus the number of people you lay off. So all of these numbers together, so this formula here, so if I rewrite this formula as WT minus 1 minus HT plus LT, this should be equal to 0. So when we write the constraint, when we put it into solver, the way we'll write the constraint is we'll say that this number has to be equal to 0. So that workforce gets balanced. So you're saying the number of people you have this month is number of people you had previous month minus the number you fired plus the number you hired, right? So that's the workforce constraint. And it's the same constraint in all the different values. So that's how the constraints have gone down. Now let's look at the production constraint. So remember that the production constraint is a less than or equal to constraint, right? So that's exactly how we are going to set it up as a less than or equal. Actually, I think this is set up as a greater than or equal to constraint. So that's fine. So the way the constraint is set up, you will notice that is you have 40 times WT plus OT over 4 minus, if you subtract PT from both sides, so minus PT, now this will be greater than or equal to 0. So the constraint will be that all the numbers that you have here are greater than or equal to 0. So you're just subtracting PT from both sides. So 40 times WT plus OT over 4 minus the value of PT has to be greater than or equal to 0. So that's what the constraint is going to be here, right? All right. Now let's look at the inventory balance constraint. So this is the one that is the most complicated one. So when I say, it's not really that complicated. When I say complicated, we're talking about, hang on, let me just, yeah, there you go. When I say complicated, it has a lot of numbers in it, but it is exactly this constraint that we have here. And let's go through that, right? So if you look at this constraint, there are 7 different things here, and there are going to be 7 different things right here. So the constraint is set up as, so F4, yeah, IT minus 1. So all the variables on the right hand side have been moved to the left hand side. So you do IT minus 1 minus IT. So this is IT minus 1 minus IT. So the IT on the right hand side, when it is moved to the left hand side, becomes a negative. Plus, right? Plus the number of items that you produced this month, plus the number of items that you have subcontracted this month, minus the demand for the previous month, minus the number of units that you number of units of inventory that you're carrying over, plus the shortage from the last month, right? So all of this again has to be equal to 0. So you had 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So it's just the same thing. Instead of having a equal to, you're just subtracting dt, subtracting st minus 1, subtracting it, and adding st to this side. So that's basically what you're doing. So all of that together is our constraint. So all of this should be equal to 0. So when we put this constraint in the solver, we'll say that all of these numbers should be equal to 0, because that's precisely what you have in this constraint. And finally, the overtime constraint. So again, it's the same thing as we have here. So the overtime constraint is OT is less than or equal to 10 times WT. So in this case, you're saying 10 times WT minus OT. So you subtract OT from both sides. 10 times WT minus OT is greater than or equal to 0. So all the overtime constraints will be greater than or equal to 0. So capacity constraints will be greater than 0, overtime constraints will be greater than 0, inventory and workforce balance constraints are going to be equal to 0. And that's pretty much it. So those are our constraints. So we have our decision variables, we have the objective function where we have explicitly written out all the cost values and then added them all up, and then we have the constraints. So let's put this into the solver and solve it. I'm just going to make it smaller so everything shows up in a single place. Data, solver. Let me clear everything because I'm going to write it differently than that. Right? So the objective function. So the objective function is right here. So this is the objective function. Remember, we are adding up all of these cost values in this place as a sum function. So that is our objective function, and we're trying to minimize our objective. Simplex LP. So the changing variable cell. So these are all our decision variables. Remember not to pick the 0th row. So the 0th row is not part of the decision variables. So it's all the rows from 1 through 6. Again, don't pick the demand values because demand values are given. It is not what do you call it? It's not a decision variable. So these are all the values that you determine. Demand values are given to you. So those are decision variables. Now let's write the constraints. The constraints are here. So like we said, we'll say that all of these workforce constraints, they have to be equal to 0. So all of these constraints have to be equal to 0. I'm going to click on add. All the inventory production constraints, they all have to be greater than or equal to 0, right? So that's how we set up. All the production constraints are greater than or equal to 0. All the inventory constraints, so that's 05 through 010, all of them have to be equal to 0. And finally, all the overtime constraints, all of them have to be greater than or equal to 0. And there you go. So we have the 4 sets of constraints that we have. We have our decision variables. We have our objective function. The only thing left is to click on solve. There you go. So the solution is here. Now notice that you have some of these numbers here. So what I would say is that you just change the format and that should work out. So I'm going to go to home, just a number. I don't want any decimal places, just the number, right? So these are all the values that I have. This is not right. Right? So this is the constraint that we have. You'll notice that there is a significant amount of stock out cost. I think we missed a constraint, but I'll take a look at that. So, but this is how you set up the aggregate plan. Now, what I'm going to do is I'm going to stop the video here. I will post a small video right after this where I will fix the aggregate plan. So I know that I missed a couple of numbers here. The video is already getting longer. I'll fix the aggregate plan. I'll post the next video, right? See you there.